Hello everyone and welcome back. We really hope you enjoyed our last episode, and today we're joined once again by Mark.
Hello everyone.
And Alex.
Hello everyone.
So we're going to deviate slightly from last week's episode, which was based on the future of jobs, and this week we're going to be talking about space mining. The topic itself is pretty self-explanatory. I don't think we need to introduce it very much. It's just the same concept of mining here on Earth, except on another body such as an asteroid. And of course that brings a lot of challenges in itself, but it could also be a very good way of solving some of the problems we have here on Earth. So do you guys want to talk a bit about why we think we should mine asteroids?
Well, I think from a very simple standpoint is the shortage of resources on Earth. Eventually, we're going to run out of materials that we use to make phones and things, such as rare earth metals. And if we can just go hopping over to the moon and sort of extract resources from there instead, I think that provides a potential solution from there. Obviously, it has its technical challenges, but if those can be overcome, then that will provide us with a whole new pool of resources, as it were.
So it's a funny name, rare earth metals. They are rare on Earth. Doesn't necessarily mean that they're not rare everywhere else. So if we could go out and explore these different places, different planetary bodies, asteroids, all sorts of these sort of things, then potentially we could find great resources out there. I need to look up this fact. I heard that all the gold, if you mined all the gold on Earth, it would fill an Olympic-sized swimming pool, and that's it. Which strikes it. That when I heard that, I could not believe it, and I checked it up at the time, and I believe that is true. So that's sort of when you start thinking about how much materials there are on Earth based on those sort of dimensions, you think there's nothing. There's hardly anything out there. So actually, we are running short on a lot of materials, not just the rare earth ones, but the ones we think of almost commonplace. Okay, precious, but relatively common. We are running out of these things. So actually going out there and mining other planetary bodies, asteroids, etc., then we could replenish those stocks that we're missing on Earth.
Yeah, I think a lot of people seem to think that all of this mining would just be for like gold and silver and platinum, which are used in jewelry, or some people might potentially think of like the technological uses of some of these rare earth elements. But I think they don't think about some of the other resources we could be mining. So for example, mining ice, so we have more freshwater supplies, or we could be mining carbon and phosphorus, which are very useful in fertilizers. So yeah, there are a lot more impacts than just, I don't know, us getting more minerals for making more phones. It's, I think, a lot deeper than that.
That's really interesting. You're talking about other materials, and we do naturally think of the most expensive things. And I think that's mainly from an economics argument. If you're going to spend billions of dollars going out there and mining these things, I'm using dollars as the global currency now. If we're going to be spending that, then you've got to be able to produce something from that that's going to be useful to mankind and is going to be cost effective. So I think we naturally go towards the precious elements. But you're quite right. As we deplete the natural supplies of fresh water on the planet, then actually maybe that could be an optional source to get more water and fertilizers and all sorts of things. The issue I'm sort of thinking about that is if you start making it an open system. So if we're not self-sufficient on this planet, is that opening us up to a whole lot of problems? If we're constantly relying on imported materials to just keep us going, is that sustainable over the long term? And do we just keep on growing and growing and growing outside of control, which could potentially be an issue?
Yeah, I think the self-sufficiency point is probably one of the main arguments, because obviously it's harder and harder to reach out further and further to into other planetary bodies. For instance, if the moon runs out of resources, obviously we could probably do passing asteroids and then maybe Mars, but Mars is obviously considerable distance further from the moon, and so you can't sort of just keep running to the next body when that body's run out of resources. It's sort of, it would be unsustainable, as it were, and sort of we still need to bear in mind that we want to sort of find a way to work with the resources that we have before actually sort of looking elsewhere.
Yeah, that's one of the arguments I think people use against space mining, and it's basically the fact that we'll deplete all of the resources in our nearby solar system, and then future generations won't be able to do the same, so they'll have to look like further and further to be able to get the same amount of resources that we have right now, or we would have potentially if we were mining in space. So why should we be... So we've talked about some of the good of mining in space, but why shouldn't we just keep mining on Earth? We haven't yet extracted everything that we have here on Earth, so why should we start looking outside of Earth when we haven't even finished covering Earth, basically?
Well, I think that the answer to that would probably be that because once if we don't start considering how we're going to mine in space now, when we it would be better to do that now rather than wait until we've run out of resources, because there's going to be a time delay between figuring out how we're going to do this in a cost-effective way and actually sort of running out of those resources. So we have to sort of consider the options now and sort of look into how we're going to do this before the shortages, our resources on Earth actually expire.
From an environmental perspective, I mean, the untold damage we are doing upon the Earth by mining these resources. Mining is an incredibly wasteful process. You're digging up tons and tons of ore, destroying millions of trees, etc., where this stuff is found, just so you can extract that little bit that you want. It's doing untold damage to a place like the Amazon rainforest. And to be honest, we need as many trees and as many things as we possibly can on this planet. There's always the argument of green agenda versus the development of nations and being able to keep everyone's prosperity flowing. When you're coming up against those two things, I think we've realised now, most people have realised now as a nation, not as a nation, as a global community, hopefully, that the environment is incredibly important. It's something we share, and it's a shared resource that we need to really look after. So I think the environment has to become much higher up on the agenda, and I think that's only going to get higher up on the agenda as we discover more and more about what the impact of climate change is going to be.
Yeah, there's a lot of societal impacts as well of mining. Like, sure, it brings in a lot of jobs, but it's also really bad for the health of the people who live around the mines and, of course, the miners themselves. So I think that's the kind of thing people don't usually consider when they're talking about like space mining versus Earth mining, because they just see space mining as taking up a lot of resources, and it itself can be bad for the environment if you're if you're using up all of that electricity to, I don't know, create the rockets or do all of the research that you need to do. But yeah, I guess it has less of a direct impact on like specific communities, and it's more of like a general global impact. So the effects of it can be dissipated slightly.
It's funny who's going to be doing this mining. If you come down to that question, we've got the idea of, if we leave it up to market forces, if we leave it up to companies to do this, then they're only going to do it when it's economically viable. So you're going to end up in a situation where there is mass shortages of certain things that we need to look for elsewhere, and the timescales involved in getting all this working, the technological advancements that are needed. If you don't sort of start that process now almost, then it might be too late. By the time we need these things, we won't be able to get to them. So there's a huge potential issue there. But then who is going to fund it? Who is going to put the money into this research to make sure that we can potentially do this in the future?
No, I think it needs to be looked into now rather than when the shortages actually reach a critical mass, as it were. And yeah, because it's only inevitable that we will run out of resources at some point on Earth. But also the whole point, the argument of the environmental damage that's done to Earth by mining. I think if you actually look elsewhere into space, as you say, you're not going to do damage to the land around Earth is one thing, because obviously you're damaging the moon instead, I guess, which is probably less. People would probably say it's less of a bad thing, arguably.
I guess one of the questions I personally have about this is whenever they state these figures such as, oh, if we mined all of the minerals on a specific asteroid, it would bring in like $1 trillion, or how much ever the minerals themselves are worth. But surely if we had such an abundance of these minerals, it would devalue the overall price, because the supply would be there but the demand might not meet it. So yeah, like, how do they come up with these figures? How do they say that it's viable for them, like they'll make money off of this specific mission, if potentially when they bring the resources back they're not worth as much as they thought they were?
Yeah, the whole argument of supply versus demand. How much of these materials do we actually need? I suppose if anyone was doing it cleverly, they wouldn't, for example, send it all at once. These things are going to take time to produce. They could send back discrete packages whenever that it was needed. So I think, if you're going to spend that money to as an investment, people are going to want a return on that investment. And I think hopefully they're savvy enough to make sure that they don't just flood the market with all the materials all at once. But yeah, it's something definitely to consider. How much of this material do we actually need? And is it going to be worthwhile doing if we can succeed?
Yeah, I mean, it's still difficult, because I don't know how the figures are determined. Are they just looking at the worth of the materials on the particular body, or are they sort of considering the costs it takes to transport those materials? Because the transportation costs of space are massive, and that's probably why we haven't got it yet, because bringing a bottle of water into space is probably incredibly expensive. So then bringing tons of new material to Earth is going to be even more expensive. So you have to sort of consider those costs as well. I'm not sure if it might be accounted for in the figure you stated, but that's the thing that might have to be considered for these things.
I understand that, but also, so you could have a £1 bottle of water that was just produced and manufactured somewhere in the UK, and then you could have, I don't know, a £50 bottle of water that was imported from somewhere really exotic. People aren't going to pay the £50 if they can get it for cheaper, because we already have a supply that is cheaper. So why would people pay all of that money? If we take into account the cost of the transportation, it would make the minerals more expensive, right? So I guess that's where I don't understand how this would all work.
That's why I've always been fascinated by the global economy, and the fact that we buy so many products from China and they're shipped over here in these massive, great big ships. You would have thought just that process of shipping it over, packaging it up, putting it in there, taking it back out again, you would have thought that would have added huge amounts to the cost. But apparently it doesn't. Apparently, we get these things cheaper because we do have this global network. And I think is humankind's next approach not a global network, but a space network where we're transporting these materials around wherever it's cheapest to produce them.
Yeah, it's interesting to sort of consider these the whole transportation costs, but I suppose the whole argument for, why would you sell a material at that cost? This whole transportation issue is the reason why nobody's actually done the space mining yet, because obviously it's just not going to produce any incentive to sell the materials for the cost of extracting them, really, and transporting them. It's just not cost effective at the moment.
So the cost effectiveness all comes down to this thing called the gravity well. So if you're launching something into space, you've got to get away from Earth's gravity, and that is extraordinarily expensive. I mean, we look at Saturn V rockets, and just how much of that mass of the rocket, over 90% of the rocket, was just fuel to get it up out of the influence of Earth's gravity. So that whole process there of getting out of the gravity well is incredibly expensive. Now, coming back in is actually slightly cheaper. So any materials that you want to import back in theory, you're working with gravity in this process. So actually, you can land these things a lot less expensively than you can if you're trying to launch something. It's still prohibitively expensive, but it is cheaper. I suppose the argument is, if you're mining something on the moon, for example, less mass, less gravity, therefore it's a lot easier to escape the gravity of the moon with these materials than it is from Earth. And I've heard a lot of people say that actually all this mining of materials, it shouldn't be for making Earth. It shouldn't be for bringing back to the planet Earth. It should actually be for creating more space infrastructure. So if we want to make things in space, if we want to make space stations, if we want to make moon bases, don't bring it from Earth, bring it in from space, because therefore it's going to be an awful lot cheaper than trying to launch all this stuff from Earth. So one of the big economic arguments for developing this space infrastructure is that the minerals are going to be a lot cheaper bringing them in than sending them up.
That's really cool. I didn't think of that argument for it, but yeah, that would make sense if we did want to explore space. I guess I have another slightly more economic question for this as well. So you know how some currencies are backed by gold? Surely if we then flood the market with gold, it would devalue the currency. So how would they go about retaining the value of their currency if we're just... I guess it comes back to the same thing of like us devaluing the elements and the minerals that we already have on Earth with all of this extra supply from space.
Yeah, I think the gold standard, we've sort of moved on from the gold standard, I believe. I'm not an economist, so I don't know enough about it. But we're working on a completely different system now. We're working on stocks and shares, and a lot of things are pegged to other currencies. So actually, you are talking about, potentially, if we get this wrong, you are talking about a collapse of the global system as we know it. So yeah, it's definitely something to consider, and it's definitely not. It's potentially an unforeseen outcome that suddenly, if materials come incredibly cheap, what does that do to all the people that rely on these materials, and all the people that rely on making money from these materials? What's going to happen to those? Are we going to end up with one superpower essentially that has control of space and has control of all of that elements of things? I don't think anyone would think it's a very good idea to have a monopoly in such a thing. So should one person, one group, just be exploring this by themselves, or should we have much more of a multinational approach to this?
Yeah, it should probably be a multinational approach, because you shouldn't sort of have one entity or body in control of space and the resources in space, as that poses obviously a rather dangerous precedent if they, as you say, flood the market with gold, for instance, or some of these materials. Yeah, it's not ideal. And also just to ensure that not just a few people gain the benefits of this whole exploration of space and mining, but rather as many people as possible benefit from these advancements.
I do love your Freudian slip there. I think you said a dangerous president.
Yes.
I mean, no take-backs.
No take-backs, no.
But yeah, that's true, because currently the way our system works is if this was a viable option for countries or companies to do, then it would only be the rich who would be able to take part in this, and so the rich would benefit from this system. So countries such as the US or China, who have the resources to be able to go out and do this, would benefit from the system the most. And then other countries who may not already have space programs or may not have enough money to go out and fund their own space programs would be at a loss from the system. And so I think we need to, I guess, have like global agreements and treaties in place in order to try and make sure that everyone would benefit from the system, but that would require everyone to be on board with this. And I think if we look at anything in the past, like what do they have? They have like environmental conferences and treaties, and you just need like 1 or 2 countries to say no for like the whole thing to start falling apart. So yeah, I can definitely see a few countries thinking, oh, it's in my best interest to not be on board with the rest of the world.
Well, in short, I don't think there is necessarily a way of guaranteeing that every country is on board. I suppose that as a result of that, one of the reasons that would give you all the more reason to actually look into that yourself, as it were, because you certainly don't want to sort of have these things exploited by people with some ill intent, as it were. So as a way of sort of, you need to have some measure of control over this, and so if you're not in the playing field, you won't have any control over it. But obviously, if in an ideal world we would have some form of sort of formal agreement, but the way the world works right now, I can't see all countries coming together and agreeing on one common framework for this to work.
I hate to sound like a broken record, but I think sci-fi's got there before us. There's numerous books and things already published on all this type of activity. I mean, one that definitely springs to mind is the Expanse series, written by James Corey, and he's talking about how we've started exploring space, and all these sort of the backstory behind all this is how all these factions have been set up and how all these bits and pieces are trying to fit together and live with each other, not only as a country but as entire planets. It's a really fascinating backstory to something. And there's another one that I read recently, Blue Remembered Earth, and that's by, I think it's Alistair, let me get the name right. So it's Blue Remembered Earth by Alistair Reynolds. And again, this was talking more about a company. So we had a one particular company that monopolized space exploration and became incredibly rich off of this one thing. And again, it's only the backstory to the main, this is what's going on. And a lot of times you'll find this, that science fiction has this incredibly well structured backstory, and it doesn't necessarily go into all the details about it that would be boring, but they incorporate it into something, a bigger story. So there's lots of really good stuff out there, and obviously people have been thinking about this for quite a long time, and it's a really, really fascinating subject.
Yeah, they would have done more research than we have for this, so they might have more ideas. I guess something else to think about is, so a lot of the bodies that we would be mining from would be quite close to Earth, so especially right now we don't have the resources to start mining from the asteroid belt directly. We would have to be looking at like the moon, as you mentioned, or NearEarth Asteroids. So how do we account for the fact that we might be altering the paths of these bodies? And yeah, like we might be altering the paths of them, so we obviously don't want them to collide with Earth. Yeah,
I mean, the way space is constructed, it's a very delicate balance. There's the gravitational interactions between things actually are something incredibly important. And actually changing even slightly something's gravity can have a change in its trajectory. So actually, I remember in my viva for my astrophysics undergraduate degree, one of the questions I was asked was, what would happen if we mined the moon and brought the material back to Earth? Now, in my viva, I had no idea what he was talking about and what he was going for, and I tried to bluff my way through it. But since then, I've had time to think about it. And actually, the fact that you've got a combined centre of mass of the Earth and the Moon, if you start moving material from one place to another, you're changing the balance between those two. So you're changing the point at which they rotate around. So you're potentially, what you're doing is moving the Earth-Moon distances by changing the influence between these two. So that we probably wouldn't be able to mine enough to have a huge difference, but it is still a difference. We are playing with celestial mechanics, which is a really weird thought. When it comes to smaller bodies, things like asteroids, say we could potentially take away 50% of the mass of an asteroid, that could have a massive change on its trajectory the next time it passes something close by, and could end up being a doomsday clock just coming around waiting for it to hit us on its next pass. So we've got to be incredibly careful if we're changing these things, that we don't cause a disaster that is unintentional.
Yeah, that's. I think the whole moon, the reduction in mass point was quite an interesting one, because I was always when it was mentioned, I was thinking more of you land on it and what happens to the trajectory there, but obviously actually extracting the material is going to change the mass, as you said. So that's probably the more perhaps the bigger factor at play here.
But no, I agree with you. Actually, if you think about it, say you're on an asteroid, you've got to launch the material from this asteroid towards Earth. That actual process, just that process of that launching, we have, Newton's third law, every action has an equal opposite reaction. You're actually going to be potentially moving it like that as well. So yeah, a great point, actually. Getting this material, just blasting this material off in a certain direction, you are going to be changing the trajectory. So that is a massive issue as well.
I was thinking more of, so actually extracting the material from the asteroid, like I guess digging would be one way, but having explosives might be another way. That might alter the trajectory. I think they have another way of doing it where they focus the sun's beams to try and I guess vaporize some of the material in the surroundings. But I guess that would also have an impact. I guess a very little one, but still an impact nonetheless. So yeah, there are many ways we could be altering the trajectories of these bodies. And if for some reason they happen to alter in such a way that they're going to collide with Earth, well, don't think that would be very good. But also, I think people are just you could just model all of the bodies in the solar system and just make sure that even if the trajectory does change, it doesn't impact with Earth. But I don't think people realize just how that's just not feasible. There are just so many bodies in the solar system that you can't possibly account for all of them. We don't even know. There are small bodies in the asteroid belt, for example, that we haven't discovered yet. And also you can't, so what is it? There's the ThreeBody problem in physics, right?
This is from I did the dynamical systems module. So when you have a three-dimensional system that's continuous, you can get essentially what's called chaos, where by definition it's sort of this. It's still deterministic, but it's just very unpredictable and has a extreme sensitivity to initial conditions. So the double pendulum, you shift that you sort of start the system ever so slightly differently, and the system evolves in a drastically different way to what it was before. And those systems, they don't have an analytical solvable solution for one, so you can't actually look at that. Numerical solutions, you could do that, but the problem with that is because it changes so much with time, and numerical solutions obviously have a finite accuracy, you're just going to get increasingly inaccurate with time. So there's just it just becomes incredibly difficult to model these systems, I think, and to any sort of reliable accuracy.
Yeah, so imagine then trying to model our entire solar system with how many other bodies that is. That would just get so crazily complicated. I don't think it would be possible to do that very accurately, and then account for the fact that, we have this one specific body that we might potentially change the trajectory for. How would that impact everything else?
Classic chaos theory. It's a beautiful thing. If you want a parallel on Earth, we have computer models now of very sophisticated computer models of weather and climate systems. However, we still don't get it right. You know this. Every single time you watch the weather, you could cross off all the times they've got it wrong. So it's really important that we understand that these things are incredibly difficult to model. The classic one is a butterfly flapping its wings in the Amazon rainforest and causing a hurricane over here. This chaos theory is a wonderful thing, and I think almost we could spend a whole episode talking about chaos theory. So I think it's probably a good idea to avoid that slightly.
Another point, actually, to add on to the point of the moon's mass being changed as well, is that the moon as a body around Earth is actually one of the bodies that sort of prevents a lot of interstellar bodies colliding with Earth, as evidenced by all the craters on it. Now, if we sort of extract a lot of the mass from the moon, I mean, perhaps it's not that much, but if we extract enough, you might make enough difference to its gravitation that a lot of these incoming asteroids and comets might, instead of colliding with the moon, now collide with Earth. That might be another thing that happens as well as an unforeseen consequence.
I'm not sure we'll be able to make that much of a difference, but I was thinking actually something like the structural integrity. I mean, if we are mining these asteroids, there is no reason why, if we mine a certain portion, it doesn't start breaking up. And when it breaks up, we don't end up with one body that we've got to worry about. We end up with multiple bodies, and any of those bodies could potentially cause a catastrophic impact on Earth. So there's all these sort of things we've got to consider as well. And this is why, actually, studying asteroids, studying the interior of them, studying the materials they're made of, how they're going to behave when we start doing these sort of things, is so important. And it's not only a nice pure research angle of wanting to know these things, but also has a practical use.
Okay, but consider this. We could have a ring around Earth instead of a moon. That would be pretty cool. I think it would bring
in the tourists.
Yeah.
Yeah.
Totally. I mean, I don't think it'd be problematic at all.
I think that's, the structural integrity point again raises the whole issue of you've not instead of having one problem, you've got two or several. So again, it just highlights all the reasons why we need to be careful.
So we're mentioning altering trajectories, but actually, let's put a spin on that. Let's put a positive on that. We might have a situation where we can alter the trajectory of an asteroid so it actually enters into a nice periodic orbit around Earth, so we can easily mine it and easily use those resources. So actually, changing trajectories we could use in our favour as well as something that we're fearful of. Sorry, I just thought so you mentioned having a ring around the Earth as a great thing. What about two moons? What about having a secondary one that we import from elsewhere that we can mine? Now, that would be cool.
That would, yeah. Oh god, the possibilities are endless.
All the interesting things that we could do.
If only we had the power.
If only. So I guess going back a little bit about who would actually be doing all of this mining, we would need a system for all of these companies to figure out who would be able to mine from where. So, for example, can companies or countries claim an entire asteroid, or would multiple countries be able to mine from the same one? Like, how do we figure that side of it out? Because I think currently, in like the current treaties, no one can own any part of space. But once this becomes a thing, I think you would need something like that. Otherwise, it could get very messy with, I don't know, people claiming that, oh, this company or this country is mining on a part that I have claimed or that I have sent my resources to.
Yes, and it is a minefield. It's such a potential problem, and we're not just talking about countries. We are also talking about companies. You know, we are talking about massive conglomeration of companies who we are trying to control using different laws, different national laws for different people. So we do need an international system of laws. At the moment, the only thing we have is the UN. So are we looking for a UN charter about space? Now, I know there are people that have looked into this massively, and there's lots and lots of people that, from lawyers' perspectives, from economics perspectives, from political perspectives, all looking at how this would be able to be achieved. So you only have to look at Antarctica, where we're potentially looking at the international treaties that are going on there. And as resources on Earth become more scarce, with particularly things like oil, we are looking actually at Antarctica as a potential source of these things. Now, how are those international treaties going to hold up when there is this competition and when there is this demand for these resources? And again, we can extrapolate that out into space.
It's interesting. Yeah, it's a very interesting one to talk about because obviously it's such a mind-boggling thing to sort of consider. It should be simple on paper, but it's so because it's just sort of involves so many moving pieces, so many nations that sort of have to agree on these things. I think, as you're right, there are various treaties and things about space. I think one of them is that space is the common heritage of man. A number of countries have signed that treaty where it's sort of like nobody can own space, as it were. I think there are a few more countries, so this is another treaty with more countries having signed it, where it's something along the lines of no country can like own a piece of space, but doesn't actually say anything about private individuals, for instance. And also, we have to bear in mind that there are lots of countries that haven't signed these agreements, so that might not stop another country from sort of saying, "Oh, I own space." On the sort of point of individuals, it might not be as simple as sort of saying, "Oh, they own that bit of space," for instance, because we have to sort of bear in mind that there's no legal framework that in a sense would enforce their claim to that sort of piece of, like, the moon, for instance. Because when you own a piece of land on Earth, you're obviously, it's like if it's in like the UK, for instance, that whole claim is going to be backed by the UK's laws and things like that. But in space, you've not really got any sort of lawful body that's going to back that claim. So you get a very dubious position where everything's sort of everything's very sketchy. There's no clear-cut answer to who would own something. I think somebody tried to claim ownership of an asteroid at one point, and then tried to charge NASA a parking ticket for landing there, for instance, and obviously they didn't pay it. But it's sort of this sort of thing that's very difficult to get a clear answer on, unless every country sort of comes together and agrees.
There are numerous companies out there that will promise to sell you a bit of the moon. Again, there's no legal enforcement behind that whatsoever. Naming stars as well. There's lots of companies that will allow you to name a star. And again, no real legal enforcement whatsoever, and no internationally recognised thing. So what I'm trying to say is, when there's a vacuum of certainty, people will try and make the most out of it. So the longer we leave it where there is this uncertainty about what we are going to do with sections of the moon, with entire asteroids, that type of thing, the longer we leave that, the more people will jump through those loopholes and start trying to claim it for themselves and start doing things that are morally ambiguous, to say the least.
One thing you can own in space, I think, is an orbit. You can own an orbit in space. But like, you have to be using it at the time. So if you're not using it, it's redundant. But you can own an orbit in space. That's one thing.
I suppose it makes sense to stop collisions from satellites and stuff. But yeah, So who set? I mean, yeah, but no, I presume no money changes hands.
No, I'll have to check actually, but I haven't actually.
Yeah. Do you pay someone to register your orbit?
Let's see. Let's look that up now.
Let's get the space lawyers involved. That's what you need to do.
Owning orbits in space. Yeah, the space ownership issue of current practical importance is the allocation slots for satellites in geostationary orbits, which is managed by the International Telecommunication Union. It's signed by several countries located on the Earth's equator, attempted to assert sovereignty over those portions, the geostationary orbits, that continuously lie over the signatory nation's territory. So a lot of countries along the equator sort of tried to sort of claim to geostationary orbits.
Is it just orbits around Earth, or like around the sun?
I think it's orbits around Earth primarily. There's another thing about if you put something in space. So if you leave something on the moon, that's still yours. That's always going to be yours.
My last point is about the impact of potentially bringing life to another body, which is something we discussed in a previous episode, but I think is relevant here as well. So yeah, once we start both space exploration and space mining, we have to be very careful about, I guess, decontaminating the things that we're bringing to these other bodies. Otherwise we might start introducing life there, and we don't want to do that. Like, we don't want to interfere with anything other than Earth in that way.
Yes, the problems of contamination potentially are there. And if you're really interested, you can look back at a previous podcast where we spoke about this.
Another thing is if you launch a spacecraft into space, there are various treaties that sort of say you have to sort of register that with the sovereign nation it's launched from, and it becomes sort of sovereign territory of that nation, the spacecraft itself. So that's quite an interesting one. So if a private company launches a spacecraft, maybe, then obviously that would presumably be territory of the country it was launched at.
And what happens if you do it from international waters, outside any jurisdiction of a country?
That would be an interesting one. That might be a way of bypassing these things. It's all.
So I hope you enjoyed listening to us, and once again, all of the opinions that we expressed today are our own, and we don't claim to be experts in anything, especially economy experts. I definitely don't know enough about that.
And law.
And law, yeah. So if we do say anything wrong, please forgive us and maybe mention it down in the comments below. I will link all of the references and resources that we used for this down below. And thank you for listening. Bye.
Bye.
Bye, everyone.